I hope you can see that. Yeah, I want to talk about fire and its suppression and vegetation. And it's so great to look down the list of all of these participants who've come in on this Tuesday morning to learn not about birds directly, but to learn about that part of nature that birds ultimately, like all of us, are dependent upon, and that is the plants that are out there. It's great fun also for me to talk about this. A few of you have been in classes that I've taken, and I guess sometimes I do get a little bit excited. And I have to tell you, this is a topic that I get very excited about. You'll also note that I've sort of adjusted the light in this room. If I have the lights on up above my head, this shines like crazy. So I turn all the lights off and I have this little shade over here and this nice ponderosa pine forest that I'm talking with you from this morning. Just kidding about that forest. As Luke said, I'm a faculty member in the School of Natural Resources and the Environment here at the University of Arizona. And I'd also like to thank someone who I've worked with for many years, actually. She's a former PhD student of mine, Candace Halbrook. She's now a GIS, a Geographic Information Systems consultant. And you're going to see some maps that she's generated that, frankly, I don't think you would be able to see anywhere else. She's really done some very unique things, and I'm thankful. So where do we start? Those of us who've been in Tucson all summer remember images like this not that long ago. And what I want to try to do within the context, yes, of the Bighorn Fire in the Catalinas, I want to give you kind of a wildland fire primer. I'm not going to be able to talk about a lot of the specifics of this most recent fire, but really what I'd like to do is to talk more generally about fires in the Southwest, how it changes vegetation, and perhaps a little bit about how things might be changing even more in the future. For those of you who want to learn more about this, there's a series of webinars coming up over the next 3 weeks. It's called Fire on the Mountain, Understanding Tucson's Bighorn Fire. This is being put on by the Institute for the Environment here at the university. It's no longer called that. I always have to look. It's now called the Arizona Institute for Resilience, and also Arizona Public Media. So they're bringing together a lot of their video and imagery from the fires. And it'll deal with many of the topics I'm going to introduce to you today. It's going to be something you need to sign up for. The URL is down there at the bottom. If you just look for Arizona or environment.arizona.edu, you'll find the links. If you go to calendar, that's probably the easiest. And that starts next week. So before the Bighorn Fire this year, for many people, folks who really never or rarely paid attention to nature, what happened in Australia in their spring, summer, and fall was really a wake-up call. And headlines like this one from the Sydney Morning Herald, and news even that I heard today, where a new report on the number of animals killed in these wildland fires, or bushfires as they refer to them, was something around 3 billion. That brought wildland fire back into people's consciousness, I think, certainly Australians, but in many areas of the world. And interestingly, if we were to look at the total area burned in those fires, it actually floats off the scale on this table. 46 million acres. a really bad year in the United States, there might be 15 million acres. So what happened in Australia in terms of acreage was absolutely off scale. And what's also, I will say, noting Siberia there from last year, what's going on in northern Russia and Siberia this year, probably the acreage will be greater than the 6.4 that we saw last year. For those of us in the Western United States, we often, especially in late summer and fall, hear of fire in California, a headline from last fall. And frankly, last fall, we could have probably every other day in October and November seen a headline like this. But again, we in Tucson had this very, very visible and powerful and for many frightening experience with the Bighorn fire. It topped out at about 120,000 acres. That's a headline from about a week ago, actually. It's officially out at this point. And for those of us in Tucson this summer, it's certainly cramped our style in that public access is prevented from much of the Catalina, certainly the Catalina Highway, until at least November. So really what I want to do today is to answer 4 relatively simple questions. And there will be, I hope, lots of time for discussion and you to ask questions as well as me responding to questions that you want to type in the chat. Initially, I want to talk just a little bit about what wildland fire is all about. And this is really rather simple, but it's also a foundation upon which really everything else related to fire and the natural environments it's affecting is built on. From there, we'll look at natural fire regimes and history of wildland fire, something we've learned a lot about in the last 20 years, actually, and how that could inform how we manage fire in the future. Certainly it will inform that, but it also tells us a lot about where we are. And that third question I want to go after, it's really 2 questions, is so what are we now seeing in the Southwest and how did we get there? And the giveaway at this point is, well, we got there because we chose to suppress a lot of wildland fires. And then finally, we'll talk about where we are going. And for those of us, you know, who spent some time in the 1950s or even the 1940s or 30s, where we are going probably looks a little different than folks who are younger than us. I won't really have an awful lot of terribly optimistic things to say about where we're going, but frankly, there is a fair bit of optimism in there. We have to try to see the best that we can that nature is throwing at us. Sort of interesting and ironic to be saying that now as we're watching this disease wreaking havoc in our culture. So, wildland fires. An image, actually an image of the Catalina foothills. For landscape scale fires to occur, and by landscape scale, we're talking usually about tens of acres or more. You got to have 4 things, no real great surprises here. The first is you have to have spatially continuous fuel, and we're going to talk about that in a couple of other contexts, but that is essentially something to carry that fire over that larger area, spatially continuous fuel. The fuel needs to be dry enough to burn. And most of our fires in the Southwest occur in that four-summer period, after spring rainfall, before summer rainfall, when fuel typically is very, very dry. We need an ignition source. In Arizona, about 75% of wildland fires are ignited by something that people have done. If we look at the rest of Western North America, it's about 95% of wildland fires are ignited by something people have done. And finally, not surprising here at all either, is weather conditions need to be favorable for fire to spread. And almost always that's lack of precipitation and sufficient wind. Now, with those sort of basic requirements, when we think about wildland fire, we sort of have two extremes. One here, and I've shown an image taken close to the ground, is a low severity fire. It's often called a surface fire. These can move over huge areas under certain circumstances, but very importantly, these types of fires have relatively low woody plant mortality. They don't kill many shrubs and trees. And we contrast, or rather, let me just show you an example. This is actually an image from one of the Daily Star's photographers taken up in the Catalinas about 2 weeks ago, Marshall Gulch, actually. And there you can see on the right evidence of a surface fire, virtually nothing other than a little bark burn on those trees and needles on the surface. That's sort of quintessential surface fire. That's in contrast to the stand replacing, or it's sometimes called a crown fire, where fire moves up the larger woody plants and will kill many of them. One of the things we want to realize about fire, and that I believe almost all of you will see when you get into the regions where the bighorn fire has burned this year, is that it is very, very patchy and very, very heterogeneous, even when a stand replacing fire occurs. So we shouldn't look at that 120,000 acre estimate for the entire bighorn fire and say all woody plants are dead there. That's simply not going to be the case. There was a lot of crown fire there, though. And in fact, here's another image that the Daily Star has. This is Samaniego Ridge looking out to the northwest, probably, I think, about 2 weeks ago. And yeah, I think in the foreground, that was clearly a crown fire. We don't know, can't really tell what was present there. Kind of looks like there was some tree felling for fire suppression based on the stumps. Now, let's go back to that connectivity concern, and let's reflect also back on what we saw here this last spring. For those of you who weren't in Tucson in the period November to March, rainfall was above average, and probably more importantly, rainfall during the winter and spring was by and large very well spaced. There were not a lot of long dry periods. And what that resulted in was an amazing profusion of summer annuals, or winter annuals in this case, not summer annuals, and lots and lots and lots of connected fuel. Great wildflower springs in the Southwest often lead to the potential for large four-summer fires. What we also saw this year, and that image, the background image was taken up at Catalina State Park, and what I saw this spring more so than I've seen in probably 15 years, and I've been here in Tucson for 36, was more presence of the European introduced grass red brome. That's what it sort of looks like from a couple of meters away in late spring. It is highly connected and highly flammable. And it was a major source for fuel at the low elevation sites on the west side of the Bighorn Fire. So what do natural fire regimes tell us? By using tree ring data and also data from lake beds and other sources of charcoal, it's been possible for researchers, many of them actually here at the University of Arizona, to tell us what natural fire regimes were like. By that, we're really meaning fire regimes before, in Arizona, before about 1920, in other areas of the West before about 1880. And fire researchers in the United States have developed maps such as this for the continental United States. This is actually a set of data, it's called land fire. And the colors on this map are down here in the lower right. It's sort of a small legend. The light green is a natural fire regime, would suggest you would have low severity fires about every 0 to 35 years. The green, the sort of olive, would be stand replacements. So now we're talking high intensity crown fires every 0 to 35 years. The yellow is mixed severity, so a little bit of low severity, a little bit of high severity, about every 35 to 100 years. The violet is that same time span, but now absolutely stand replacing fires. And then the orange, so look out in western Arizona there for that orange, that's stand replacing fires about every 200 years. And I know when we look at Arizona, it's really, especially our part of southeastern Arizona, it's really hard to see what's going on. I'm actually going to show you some fire return and severity data for the Catalinas. I just want to sort of remind you or tell you, if you don't know already, that certain species like ponderosa pine, this is a stem section from the Tree Ring Research Lab, and it's a tree from New Mexico, have bark that tolerates fire, and because of that, a series of fire scars will appear, and it's relatively straightforward knowing when the tree died or was felled to actually develop a fire return interval map by just counting the rings. And when we look at these fire scars, we can actually learn quite a bit about natural fire regimes, and also we can see how fire has changed since about 1900. So what I'm showing you here are a whole series of locations. It turns out these are more or less in latitude, high north, in the continental United States, all the way down to southern New Mexico down there, and southern Texas actually at the bottom. And each red dot there represents a fire scar. And this is dealing with the time period from about 1100 AD to about the year 2000. And let me just point out something we'll talk about from about 1900 on. If you just sit back a little bit and look at that, what you notice is, yeah, about 1900 on, in many of those environments, there's what we could describe as a fire deficit relative to where natural fire regimes would have occurred, natural fires would have occurred, and the expectations have really fallen off, and in some areas, quite a bit. Now, we'll talk about what's going on there, But first, I want to kind of hone in on the Catalinas, talk a little bit about natural history there, and then we'll look at fire frequency and answer the question, what's happened in the 1900s? This is looking straight down on the Catalinas. So north is up. The town of Catalina is there. The town of Oracle is up there. Tucson proper is down here. And there's Bear Canyon right there, Willow Canyon, Soldier Camp, and the summit of Mount Lemmon would be right about where the arrow is right there. What we have here are the vegetation classifications, the vegetation types. And so you can, I'm sure those of you who know the Catalinas will say, okay, that light blue, that's got to be some sort of desert type plant community. And in fact, it is. And what I'm showing you here are 8 different plant community types. We're not going to talk about all of them. I'm simply going to focus on 3 of them. 3 of them because they are particularly instructive, and also there's a lot of contrast among them. So the lowest elevation I'm showing you here, the essentially bottom of Push Ridge down to the Catalina High, or down to Oro Valley, would be what vegetation researchers would call semi-desert scrub. So this is shrubland with some grasses, and certainly this is prime saguaro habitat. Moving up quite a bit, actually, the darker green community type will be pinyon pines and junipers. And then we'll focus a bit on probably the core high elevation habitat that most of us have the most experience with, and that's ponderosa pine. So let's go back down and look at that semi-desert scrub community. This is an image that I took this spring, actually, just below Push Ridge. And so you can see a lot of the plants in a springtime view on a nice, cloudy, cool day. A lot of the plants that we associate with this kind of environment: brittlebush, prickly pear cacti, of course, saguaros, ocotillo, other shrubs, and a few winter annuals coming on. This happens to be a site with very, very few invasive grasses in it, which is nice. I'd like to go back there. It's in the Coronado National Forest, so I'm going to have to wait to go back there and see what this spot looks like. I doubt whether there's much fire damage in there at all. If we look at that plant community, the average fire return interval, that is, if humans were not involved in managing these fires, and that includes Native Americans managing fires in these environments, we'd expect a fire about every 150 to 200 years, probably in response to 3 or 4 consecutive years of very, very high rainfall. That's probably what would have led to a fire in those environments, but they occur very, very rarely. 150 years, that's a pretty good sized saguaro. So if we've seen lots of saguaro mortality in this environment, there seems to be some suggestion that we will from the Bighorn fire, assuming that there's enough fruits out there, enough animal migration of fruits in, bringing seeds in, and we get enough rainfall this fall, their seedlings will establish. Yeah, in 150 to 200 years, we'll probably have pretty good stands of saguaro back in that environment if nothing else changed. And it will, and we'll talk about that. That image, another really great place to see evidence of this for many of you would be Sabino Canyon. Sabino Canyon, the lower elevations of Sabino Canyon as you go up, that's classic desert scrubland going up into the canyon. That fuel conductivity can also be affected by perennial grasses. And in the Tucson Basin, we have one particular perennial grass. The brown rather, that you see here is that one perennial grass. It's not native to this environment. It's called buffalo grass. It's very, very flammable in late spring and early summer. It's also, as a mature plant, quite tolerant of flame. It survives fire really, really well. Its grains survive fire really, really well. And there's no question, especially on the west side of the Bighorn Fire, that patches of buffalo grass gave that fire increased connectivity, made it more difficult to fight initially when it was small, and when suppression was really sought. I will say about buffalo grass that we're in a very, very unique environment for this plant. It's about as far north as it can go. Winter temperatures keep it from going higher in elevation than we see it here, or much farther north, especially north and east. We also have in Tucson a collective sort of group of the public and natural resource management agencies who are very aggressively trying to eliminate this plant. And I think we can, within a generation, get rid of buffalo grass. The technology is available. The wherewithal to do it is not, we're not that far away from having it. I've seen this plant in Central Australia where it's invaded and covers tens of thousands of acres, continuous. You can't simply throw a rock and not hit a buffalo grass plant for hundreds of kilometers. And we don't have it anywhere near that bad. We can get rid of this plant. And I'm actually quite hopeful that we will. We've made a lot of progress. If we look at the semi-desert scrub community type, what I've done here is overlain the Bighorn Fire perimeter. The little open area here in the center, sort of from Willow Canyon up to Mount Lemmon and a little bit farther west into the wilderness of rocks, that did not burn. This is just a perimeter map. We don't have an actual burned, unburned map yet for the Catalinas, but you can see there are a couple of other areas where there was a perimeter inside. So you can see that, yeah, it moved into the semi-desert scrub, especially on that west side and on the far east as well. Now let's go up in elevation to a very different appearing plant community. We're up around 4,000 feet here. This is that's Mount Kimball in the background, for those of you who know the west side of the Catalinas. And this is Mexican pinyon pine and alligator juniper primarily. That's what the two large woody plants are. And this is a very different fire return interval. So in the semi-desert shrubland, we're looking at 150 to 200 years. Now, we're looking about, every 40 to 50 years. Some of these fire return interval classes make it look a little more precise than it really is. I like to think not 41 to 45. We're really looking at about 40 to 50 years here. And that image that I showed you was, there's Mount Kimball in there, that reddish diamond down in the southwest. And then finally, sort of the quintessential high elevation habitat that most people recreate in the Catalinas, and frankly in all of the Sky Islands of northern Mexico and southeastern Arizona and southern New Mexico, and that's ponderosa pine forest. And now the average fire return interval is half that what we would see in the pinyon juniper. It's about every 15 to 20 years. We'd expect a fire every 15 to 20 years, and most of those would be low intensity. It's not to say that there would never be a high intensity or crown fire, but about every 15 to 20 years, there would be a low intensity fire. All right, so with that background, where are we? And the image that I showed you was just at Soldier Camp, actually. That image was taken about 10 years ago. What are we seeing now, and how did we get here? I've already kind of given away. Yeah, we started putting out fires in the United States, in the Western United States, and that's largely how we got here. And to understand that how we got here, it's useful to go back and look at some of the history of natural resource management in the United States. And so much of fire management can be traced back to one person, a very amazing, larger than life personality in many respects, a man named Gifford Pinchot. And he was the first chief of the Forest Service. They still call their head administrator the chief. And a series of fires in the 1920s and going then into the 1930s, long after Gifford Pinchot was chief of the Forest Service. He actually was not in that long. It turned out that there was a mechanism to make the US Forest Service much more powerful politically if they were seen as protectors of the forest. And so, beginning with Gifford Pinchot's ideas about forestry, which were largely brought from Western Europe, and then the realization in the early part of the 20th century, in the teens and 20s, that, hey, we could make the Forest Service powerful in Washington if we were seen as protectors against the great scourge, the wildland fire. We began something that all of you, I'm hoping, will remember, and that is a public outreach campaign that, in this case, Smokey the Bear first appeared in 1944. This is a poster from 1955. And we also began, especially in the 1950s and 60s, bringing all sorts of technology to bear on fire suppression. The idea that there's a 10 o'clock rule. From the 1930s on, in the Forest Service, there was this 10 o'clock rule, and that is, we want to put out all wildland fires by 10 o'clock the next morning. And we're going to do all that we can to do that. That rule was basically in place for 40 years. It was eliminated in 1977. Certain elements of fire suppression, many of you, if you were in Tucson over the period of June into early July, you would have seen equipment like this associated with wildland fire suppression. The technologies used are amazing. They're often much, much more effective when suppression is an objective, as it certainly was in many cases in the Bighorn fire. Interestingly, in some respects, wildland fire suppression has not changed much for hundreds of years. Certainly in the United States, it hasn't changed at this level in well over 120 years. And that is simply taking away the fuel and building a break. That hasn't changed much. And it turns out that if we look at what began in the Forest Service in the 1920s, the so-called fire suppression era, that in some areas of the West, it started earlier. In California, it actually started in the 1870s and 80s. It went to about 1990. Some folks will say that what happened in Yellowstone in 1988 is kind of a threshold point. Huge fires affecting about 35–40% of the area of Yellowstone Park that year. And precipitation put it out after lots and lots and lots of suppression effort that really didn't work very well. That really was the beginning of a change. If you look at the acreage, you can sort of see that, yeah, we bottomed out. Averaged over decades, we bottomed out in the late 70s, early 80s. We'll just blow that up. You know, an average year has about 8 to 10 million acres burned. This is just the period between 1980 and now. I've added 2019 and 2018 there. Remember, 40 million acres in Australia this year. That's off the scale by a factor of 4. I mean, that was truly an astounding amount of acres burned. So what does that mean? Well, for one thing, it means that natural resource management agencies like the Forest Service, they don't have much money to do anything other than fight fires. This is the cost of wildland fire. This is mostly suppression. They talk here about preparedness and a program called FLAME. It turns out that 95% of what you see there is actually fire suppression. There have been efforts to get the Forest Service budget separated from fire suppression, or get fire suppression taken out and put into another governmental funding agency, and it's slowly moving forward. I think, given what's going on in Washington, I wouldn't expect anything until, well, knock on Formica, until January. Certainly nothing's going to happen this year. So what does it mean? What does all this suppression mean? Well, what it means is that the fire return interval, the frequency of fires, that will increase. Fires become less common. That means more fuel accumulates and it becomes more connected. When ignition occurs, with that artificially, that fire suppression leading to that high amounts of fuel and high amounts of connectivity, you get bigger fires and you get fires that are more severe. So what would have been a surface fire now becomes a crown fire. What would have been a small fire then becomes a big fire. What also is sort of superimposed on all of this in many areas of the Western United States is something that natural resource managers talk about a lot, and that's the wildland-urban interface. This is an image I hope none of you, I'm hoping I'm not showing your house in the Tucson foothills, but this is sort of the classic example of living right up against, in fact, in the area of Push Ridge, living right up against a near wilderness with this. What that means is the chances for ignition increase, the damage associated with fire increases, because now we have many thousands of dollars, if not many millions of dollars worth of value on every acre. And that makes the fire threat worse. Essentially, when the wildland-urban interface grows, that causes a loop around where there's more fire suppression on the edge because we don't want to burn things up where there is the value. You all, if you're in Tucson, saw this happening as neighborhoods in the Catalina foothills were being handled very, very differently than areas up in the wildland environment. Lots and lots of resources. I remember going up and watching, it was so ironic and funny at one sense, watching a helicopter come into the Ventana Canyon Resort and pull water out of the lake on the golf course to run it up into Ventana Canyon and atop of Sabino Canyon to do fire suppression. It's kind of one of those cases where being close to the wildland-urban interface had some advantages. Now, what's happened in the Catalinas? It turns out we've got pretty darn good fire records beginning in the 1920s. And what I'm going to show you now are areas burned in a 10-year period beginning in the 1920s, and we'll do it every decade up to the 2020s. So the 1920s, pretty big fire up there in San Diego Ridge and the upper elevations of the Cañada del Oro Wash, an area that burned this year as well. 1930s, a little bit over there in the southwest, pretty big fire, just east of what is now Oro Valley. I don't think Oro Valley was much of anything as a town in the 1930s. The 1940s, I just showed you the 1940s. And if you talk at natural resource and fire managers who know about the history of the Forest Service, they will say the 1940s was the ultimate time for fire suppression. If you look at fire throughout the Western United States, you tend to see the lowest total levels on many sites, especially in the Southwest in the 1940s. Look at that, 10 years, almost nothing. In the 50s, scattered fires, mostly at higher elevations. The 1960s, a couple of big fires up just north or south of Oracle. Interestingly, you might want to sort of focus on the area over here in the southwestern corner. And you might want to wonder, how long has it been since some of those areas that burned in the early stages of the Bighorn Fire burned? Here's the 1970s. I'm guessing that some of you might even have some memories of some of these fires, especially that one there southeast of Catalina. The 1980s, I remember these fires. I came here in 1984. I remember that fire going up mostly in low elevation habitat south and east of Bear Canyon or towards the Catalina Highway. The 1990s, and then the 2000s. I'm going to look at that again. So that was everything from the 20s through the 90s. And then there was the Bullock Fire and the Aspen Fire. It's basically two fires in 2 consecutive years that covered a huge area. And many of you, I'm sure, remember those fires 17 years ago on the Aspen Fire. The Burrow Fire in 2017 is what we see mostly there at the southeastern edge, an area that reburned again in the Bullock Fire. And then again, let's overlay all of that historical fire to what we saw this year. And again, I would focus you on this area in the southwestern finger of the Catalinas. Large areas of pinyon, juniper, and other plant communities at slightly higher elevations that really haven't seen fire since before the 1920s. That's partially why there was so much explosive growth early on this fire. The fire initiated over in here, relatively low elevation off of Oro Valley. Now, superimposed with all of that is this. And these are warming stripes. This is a really great visual tool that a meteorologist in Great Britain has developed. It's essentially looking at average temperature. If it's warmer than average, it will be red. If it's much, much warmer than average, it will be much more red. Likewise, if it's cooler than average, it will be very, very blue. And you can see that especially since about 1995, temperatures in Arizona have been getting warmer and warmer. And while this figure is a little bit complicated, we're really looking at soil moisture. And if you follow just the red line, this is telling us, yeah, that we're in an 18-year drought right now, that it's about as bad as we've seen in more than 1,000 years. So dryness and heat are 2 elements that make for serious wildland fire. And again, if you look at just those 2 factors, this is temperature and precipitation for Australia. And this averages over the entire nation. Look at that weird 2019 point. It's about as hot as it's been and about as dry as it's been since 1910. And they saw massive, massive fires. So we've got a second sort of threat multiplier, and that's climate change. It lengthens the fire season. It makes the fuel drier. You get with increased temperature, you're going to get bigger fires and more severe fires. You're also going to get more carbon dioxide emitted, which makes the warming even worse. So when we look at what's happening in Siberia right now, it's that times 50. Climate change really absolutely driving those fires as well. Now, where are we going with all of this? And I wish that I could, again, give you lots of really optimistic pronouncements about where we are going. And the reality is we often really just don't know. Biologists and others who study wildland fire are used to dealing with complex, multifactorial problems, because that's what we've got. And I kind of want to just show you some of the easier things to understand. This is an old image taken in 2000, so that's before the Aspen fire came through Soldier Camp. Scattered ponderosa pine, you can see some bracken ferns. You can see not very much litter, not many needles on the ground. You can see some fire scarring in here, which says, yeah, there was probably a fire in there. I think that area had burned about 30 years prior to that, maybe 40 years. And what we're really seeing a lot of in burned areas in the western United States is fire-driven vegetation conversion. Taking a forest like this with an unusual fire regime, having a much more severe fire than would be expected otherwise, and having the vegetation that comes back being quite different. You can actually see it, or at least I was able to see it this June. This is an area not far actually from where that previous image was taken 20 years before, where it burned in the Aspen fire, high intensity burn. It's now being invaded by Gamble oak and New Mexico locust, which are two pretty aggressive shrubby small trees that will quite effectively keep pines from moving out for probably a decade or two or three. The first place I'm going to go as soon as I can get back into the Catalinas is right back here to see if it burned again. My guess is it probably wouldn't. The fuel was just not dry enough. Also, same trip early this June is actually, I went up there when the fire was burning out on the southwest side and the Catalina Highway was still open. You can still see some snags, so these are standing dead trees, but also some still live ponderosa and southwestern white pines, and then just this mat of shrubby oaks and locusts underneath. That sort of conversion is really pretty common in a lot of mid and high elevation environments in the Southwest where intense fire has come in. Changes in the community type. So you essentially have high severity fires that takes a lot of the mature vegetation out. Then all sorts of things will affect recovery of what was there. So there may not be seeds, there may be fires that occurred too soon after the previous one. There may simply be changes to the environment where seedlings can't recruit. Often it can be as simple as the soil has gone away. Any of you who were in Tucson who went out to the Rito or the Cañada del Oro wash in the last week, since last Thursday, you can see a lot of that soil that has come down. That is not the sort of thing you want to see if you want to get those previously present plants recovering. So what I've described to you is a simple example of that community type change. You get a ponderosa pine forest that gets a fire over time. you end up with an oak woodland. And that oak woodland may persist for a very long time, decades to centuries. We don't have a lot of examples to know whether or not we're going to loop back to a ponderosa pine forest, whether if we bring in a more natural fire regime, we can actually try to support that ponderosa pine forest. Much of the management in the Catalinas is focused on protecting ponderosa forests, much of it based on thinning to reduce the stand density such that when a fire comes in, there will be lower intensity and there won't be crown mortality. But again, if you think it's that simple, well, you're not paying attention. I like to challenge my students by saying, if you think you've got a simple solution, you're not paying attention, because these are really complicated problems. Because what's happening throughout that time is the climate is changing as well. And so there are a lot of examples where we don't need to see fire, and we're still going to have transformation from ponderosa pine forest to oak woodland. And we know that in the Catalinas, basically plant communities are moving up, which means they're moving as it warms to higher elevation. And at any given elevation, what is happening, it's being replaced by the plant community coming from lower. Those right at the summit, the fir and aspen communities right at the summit, they truly have nowhere else to go. They can't go up, and they could simply disappear regardless of what happens to fire. One of the ideas that a lot of vegetation scientists have is that fire may actually accelerate this. So that climate change might take 30 years to go from ponderosa pine forest to oak woodland. With a fire, as we've seen in the aspen fire, it might happen in 15. And I think there's quite a bit of data to now support that in a lot of communities throughout the West. So some images. Again, these are journalist-driven images of, this is not aspen fire, this is actually bighorn fire. Yeah, so tough changes on those communities. But still, there's an image like this, that this actually is something I pulled from a Forest Service bear video. Bear is burned area emergency response. So right after the fire, the land management agencies get bear teams together. They go out and assess what needs to be done to stabilize sites where fires occurred or where suppression activities have occurred. And what's really neat is that we've got these bracken ferns coming up, probably in response to a rainfall event about 10 days ago, 2 weeks ago. And we also have, I can't identify what these small shrubs that are root sprouting here, but they're coming up. So I guess I would say we should be very, very careful when we look at these moonscape images that a lot of the journalists have presented. Get down on the ground and scratch the surface, or as in this case, you don't even have to look at, you don't have to scratch the surface. You can see that recovery is occurring. Bracken ferns that have a lot of stems, usually about 2 to 3 inches below the surface, can do quite well and survive really relatively hot fires that move quickly over them. So let me just quickly summarize what I've tried to present to you in this wildfire primer. Wildland fires result from an interaction of fuel and weather and ignition, and it's almost never a simple interaction. I guess I would have to say that the bighorn fire, what we know about it right now, is that it frankly was pretty simple, and it was also a natural ignition. It was a lightning ignition. There is a wide range of natural fire regimes, and the vast majority of forested environments, especially in the Western United States, there's been a departure from that natural fire regime over the last 100 to 120 years. Fire frequency and fire severity are increasing in a lot of environments due to fire suppression and climate change. In some cases, like Siberia right now, it's probably mostly climate change and not fire suppression. And then finally, I think the thing that is probably most challenging to those of us who think of ourselves as naturalists and observers of nature is this fire-driven vegetation conversion. It's being influenced by a lot of things. Fire frequency is sort of what we've focused a little bit on here, but also fire severity and finally climate change. Again, I would encourage all of you to sign up for this. I think it'll be really interesting. It's going to have a lot of really good visual material. Don Falk, who's a fire scientist, a fire history person here in the School of Natural Resources, he's going to be quite prominent in these webinars, and I would encourage you to participate. Also, I'm more than happy to try to answer any questions you might have down the road. I'm going to hang around as long as you'd like to answer questions right now. But don't hesitate to send me an email or give me a call. And eventually the university will be back in business. But I want to tell you, this part of the university is back in business. I'm doing my job, getting ready to teach field botany laboratory to 107 people who I will never see in person. So that's a big challenge. Let me look at the, I see a couple of things in the chat, and if you've got a question you want to ask, go ahead and raise your hand and Luke will let you in. Did we lose a lot of saguaro in the fire? That's one common question. I've talked to a couple of people who've been up in burned areas right around Push Ridge. And the answer, I guess, that they gave me that I would give you is, yeah, there was definitely saguaro mortality. Are saguaros going to disappear from that environment? The answer will be no. I think that what we really want to look for will be what our fall and winter season looks like. If we can have a reasonably normal monsoon precipitation that goes into the fall, that will help saguaro seedlings to establish. And if we have a relatively warm winter, most of those saguaros will survive. Saguaros have sort of two major hurdles they have to cross over. They have to get enough water, and it has to be sustained when they germinate, right about now through September, October. Then they need to be able to survive low temperatures in the following December, January, and February. If we have a relatively warm December and a pretty nice late monsoon fall, I'm thinking a lot of saguaros, either ones that are seedlings establishing or even ones that are partially damaged by fire, their chances of surviving are much, much better. Can you explain the practice of Native American controlled burning and what its current status is? And I can give you a very brief response there. It's rather complicated depending on where you are. So if you're in the northern Great Plains, there's no question that there is a long history of fire management by Native Americans. Likewise, in the Pacific Northwest and in areas of California, a long history of fire management by Native American populations. In both of those areas, fire management being done by natural resource agencies, including those on the nations, are going back to more traditional fire management strategies. In the Sky Islands, we have relatively little evidence that there was ever much Native American management of fire, either from populations that were migrating into the Sky Islands from lower elevations or from fires begun on low elevations. As a purposely begun. There were certainly wildfires, there's historical record of wildfires, but they were not purposely set. That's actually an area, Native American fire management is actually a very, very active area of research, but also Native fire management in Australia has become a very, very active area of research. Likewise, long history of fire management in many areas of Australia. Did the building of the Catalina Highway and the activities of the CCC in the 1940s have the effect that we see the decrease in the fire activity? Absolutely, it had a large effect. Having the highway being built during that period and having a road that went up during that period allowed for fire suppression to occur. But the reality is that there was just an awful lot of effort beginning in the middle 1930s actually brought into the Coronado National Forest to suppress fire. And they were moving very, very quickly into those fires. The roadway certainly helped. There's no question about that. The interesting thing for me is I look at what happened since the late 1990s when the highway obviously was there, and saw the amazing growth in the large fires in the early 2000s. Had the highway not been there, there's no question the Aspen fire and the Bullock fires would have been very, very different. No question about that. Stinknet as a fire carrier. Stinknet is this really awful plant that is a problem now in some areas around Tucson. It's much more of a problem in Maricopa County and in areas south, especially in Casa Grande. In terms of its effect on fire transmission, no, I would not be concerned about stinknet in that regard. Down here, I think that it could in late spring in areas where it's invaded in Maricopa County, it could be a pretty significant problem. The thing about stinknet is it needs to have a really disturbed soil. And so it's not likely to move too much into a wildland, classic wildland environments. I'll say that we're at a point with stinknet where we were with buffalo grass 20 years ago. And a lot of folks in Maricopa County are really, really, truly going after it. What about building codes? Yes, that's always a question when we think about or talk about the wildland-urban interface and fire. Remember, it's not just fire. Wildlife issues in the wildland-urban interface are quite significant. Building codes in Arizona have had relatively little effect on how fires get managed and or how fires occur. There's also in most areas of Arizona, certainly in Pima County outside of Summerhaven, building codes to protect the structures are relatively lax compared to what you might see in California, especially in coastal California. I think that what we saw earlier this summer in the Bighorn fire, especially in the Catalina front, sort of on the south side of the Catalinas when there were large-scale evacuations, what we saw there was not really a reflection of anything about those structures, how they were built, how they were protected, how they were not protected, whether they were walled or not walled. It was, the fire management was driven by where they were, with simple presence. And they weren't going through and marking houses, oh, this is stone and has a stone wall around it, therefore we can ignore it. It wasn't that way. So that's a pretty tangential answer to what is actually a pretty complicated and fairly politically charged question. What are the views of other federal and state agencies regarding fire? Are they all on the same page? And that's a really, really good question, because when we look at fire in Arizona, we're looking at the state land department, which is what they used to be called. They're now called Forestry and Fire, State Department of Forestry and Fire, the Bureau of Land Management, the National Park Service, and the Forest Service, the U.S. Forest Service. They all can interact along with county fire suppression people and even city fire suppression people. By and large, I think almost everybody is on the same page that we're now at a point where if a fire is in an environment where we're not going to see likely threats to economic resources, we're likely to let it burn. And in many areas of the West, at certain times of the year, in certain environments, fire suppression that even 10 years ago would have been initiated is no longer. Now, COVID is an odd situation. That's quite a statement. But what's going on this year is that there is a lot of effort by fire management agencies, natural resource management agencies, to keep fires small. And the reason for that is that large fires mean large congregations of people, which means increased COVID risk. So I think what we're going to see this summer, we're already seeing it in California, is there is an awful lot of rapid suppression. A lot of folks that I've talked to, actually, who will only speak off the record, believe that the Bighorn fire could have been put out earlier, much quicker, with a much more aggressive first attack. And these are fire people saying this. I'm not going one way or the other. And it would have probably reduced the COVID infections that were associated with the fire, and there were some as people congregated. I'm hoping, as you are all, that COVID is something we'll have under control by next fire season. And we'll probably see those agencies go back to a much more natural fire regime when the economic resources permit it. Long history of Native Americans controlled burning in Maine on blueberries. That's absolutely the case. And interestingly, some recent research, if you look at vegetation change in the continental United States and you go to the east, the effects of Native Americans on land management are greater than what has been seen there so far with regard to climate change. If you go to the west, the effects of climate change are actually greater than what could have been associated with either Native American land management or post-Columbian European management. It's kind of this interesting east-west dichotomy. Still burning blueberry fields every other year in Maine. Yep, absolutely. I think one of the things that I always try to bring to discussions of wildland fire is that not all fire is bad and not all fire is good. I think that when we look at a lot of journalism as it relates to wildland fire, for a lot of good reasons, we see that the reality is it's almost always presented as almost always bad. And that's not always the case by any means. The impact on wildlife, yes, specifically birds. So right now, my friends in the Coronado National Forest that I've talked with, I talked with one actually yesterday, on Monday. They don't know much. They're working on an owl project, and they just don't know much at all about movement of birds at all. And so it's too early. My guess is that by October, we're going to know a lot more. The wildlife biologists are going to be going up there, and they're going to be able to tell the public what they're seeing. I would think, given the scale of this fire and the sorts of diverse environments that it's affected, we're going to see lots and lots of patches of everything out there. There's already been some evidence in the news, you've probably seen it, of part of the bighorn population, that bighorn sheep population that's moving around. They're easy to track, easy to map. We know where they are, pretty much, most of them. And they seem to be doing fairly well. The Arizona Game and Fish folks who track them are fairly optimistic. You know, like all disturbances, I think that what matters is to try to take the time scale of nature, in that what we see in animal populations or plant populations in the next 6 months, well, that's just the beginning. And frankly, what we see, I don't know, a year or two is still just the beginning. What we see 5 to 10 years from now, that's sort of where I might start to think I'm seeing some sort of measurable transition. We know that certain birds will absolutely thrive in a lot of these environments. I would expect you're going to see woodpeckers like you've never seen moving into those dead snags and other lone trees in burned areas. It's going to be great woodpecker habitat. Lots of insects, probably a lot of bark beetles may move into some of those stressed trees. That'll be a good thing for woodpeckers as well. It's a little bit, it's actually way too early. Smokey the Bear's mottos changed to be wildfires, used to be forest fires. Yeah. So when teaching youth about invasive plants and their correlation to fueling fires, what would be your biggest point to drive home with them? I think if those youth are in Tucson, there's no question that we look at invasive plants in our environment and we can make a difference. Individual plants, individual people can really truly make a difference. We look at buffalo grass, we look at stinknet, where our really serious invasive plants, red brome, not so easy to make a big difference. But when we look at buffalo grass, we can really do things that will truly make a difference. If the weed whackers were not out there working on buffalo grass for the last 20 years, the Tucson mountains would look very, very, very different than they do right now. And people did that. And that's what probably I would say to anybody who's concerned about invasive plants. Red brome is an interesting plant in that I remember when I first came here, in some years we'd see a lot of it. And until a couple of years ago, I actually thought it had more or less disappeared. We didn't have that many good winters and springs for red brome. And it was sort of like, where is all the red brome gone? Well, it was living in the seed, in the soil, and in the seed bank. And this year was perfect for it. It came on. That's a plant, an invasive plant, that frankly, we're not going to be able to easily manage. Although there are some ideas about burning it relatively early in the spring, when there's still a fair moisture content in it, get essentially a surface fire that kills a lot of those plants just as they're becoming ripe. And that might actually be a reasonable resource management strategy for red brome.
Hey, Steve, thanks so much.
Absolutely. I had fun talking about it. If you've got any questions, hey, send me an email, get in touch with me. I'm happy to try to talk more.
Awesome. Yeah, I'll include your email address and a link to the wildfire seminars in the email that I send out later on this afternoon, along with the recording of this session. So I'm going to take everyone off of mute so you can verbally tell Steve thank you. There you go.
Thanks so much.
Thank you.
Thank you. It's good. It's good fun.
Thank you, Steve. Thank you, Luke.
That was really good.
Thank you.
I just want to tell you that it's great for me to talk with Arizonans, because I work for you. I'm a faculty member at the university, and you are who I work for. So It's great fun, and let's go out and enjoy nature, huh?
All
Yeah,
right.
thanks,
Thank
Steve.
you.
Great.
Thank you.
Thanks.
Thank you so much.
Yeah, enjoy.
Bye.
Bye-bye.
See you guys later. Thanks again,
All right.
Steve. And
Yes.
hope to run into you again soon.
Yeah, thanks, Luke. Appreciate
All right.
it. We'll see you.
Take care, everyone.